Hi Chem Team. It turns out we can use the periodic table as another way of writing electron configurations. It turns out that the periodic table has been structured in a way that reflects electron orbitals. For instance, this left-hand column on the periodic table is called the S block of the periodic table, representing S orbitals. So the first row represents the first shell's S orbital. The second row represents the second shell's S orbital. And this continues all the way on down through the seventh shell's S orbital. Meanwhile, this chunk of elements over here is called the P block, and that represents P orbitals surrounding an atom. With this row right here representing the second shell's P orbitals, the next row representing the third shell's P orbital, continuing on down. Then we're not going to discuss it at this level of chemistry, but the center block of elements is called the D block, which represents a type of orbital we haven't discussed called D orbitals. But most importantly, these orbitals have been arranged in order from most stable to least stable. So the most stable orbital, the first shell's S orbital, is in the upper left-hand corner of the periodic table. And then as you read left to right, orbitals grow less stable. So the most stable orbital is in the upper left-hand corner, and the least stable orbital would be in the lower right-hand corner. What this means is we can use the periodic table instead of an orbital diagram to find the electron configuration of an atom. So let's say we wanted to find the electron configuration of neutral fluorine. Since fluorine has an atomic number of 9, it has 9 protons in its nucleus that would attract 9 electrons. Now these electrons will fill into the most stable orbital first, which in this case is the first shell's S orbital. Then once that orbital fills up, electrons will fill into the next most stable orbital, the second shell's S orbital. And once that fills up, they'll fill into the next most stable orbital, the second shell's P orbitals. Then the third shell's S orbital, and then the third shell's P orbitals, and the fourth shell's S orbitals, so on and so forth. So let's do that. The first 2 electrons will attract into the first shell's S orbital. The next 2 electrons will attract into the next most stable second shell's S orbital. And then the remaining electrons will attract into the second shell's P orbitals. Now, writing the electron configuration works the exact same way that it did in class. Since the first shell's S orbital has 2 electrons in it, we will write it as the first shell's S orbital having 2 electrons. Since the second shell's S orbital has 2 electrons in it, we would write it as the second shell's S orbital having 2 electrons. Okay? And then last, since the second shell's P orbitals have 5 electrons in them, we would write this as the second shell's P orbitals having 5 electrons. And that's it. At this point, you guys have a couple of practice problems. We'll see you in class tomorrow.